الرحيم والصلاة والسلام على أشرف المرسلين. Monsieur Blعور, vous allez soutenir votre habilitation maintenant devant les membres du jury composé de Monsieur Nouri, المشرفين de l'université de Batna, et Monsieur Moulihobi Daoudi, professeur université de Msila, et Monsieur notre collègue Lekhal, université université de Galma, et moi-même Monsieur Hita Amara, professeur université de Galma. Vous avez 35 plutôt minutes pour présenter votre travail. Tfadal, pour faire bien.
Merci beaucoup, Monsieur le Président. Bismillah ar-Rahman ar-Rahim. Dear respected professors, my teachers, my colleagues at work, my supervisor, thank you so very much for being here in such bad situation with Corona. I would like to express my deepest gratitude for attending to this presentation for my university habilitation. And of course, this is an opportunity for me to talk about my interest works. So, as usual, I start with by describing different sections of the presentation. So, I'm going to talk about my personal and professional information, academic degrees from Living Scholar Certificate, Baccalaureate, in 1997, up to Doctor of Sciences in 2015. I will talk about my teaching of experience and all the basis courses of mathematics that I have taught since 2003 up to now. Then I will look at my lecture notes and supervision with master students. Next, I show you my fields of interest and explain the famous results of my research activities that I have obtained before and after my doctoral thesis. But I will definitely give a hint to some and focus on the main work that has come after my doctoral thesis. Also, I show you some selected talks at national and international conferences. At the end of this presentation, there is an important section includes my future research and perspectives. So, in general, I have 5 published papers in refereed journals, and also I have a new paper which is recently accepted. And I participated in 5 international conferences and also 5 national conferences, and engaged in 2 scientific collaboration projects. I taught 6 different basis courses in mathematics, respectively linear algebra for economic sciences, numerical analysis 1 and 2 at Department of Mathematics, algebra 3 and 4, English 1 and 2, and algebra 1 and 2 at Department of Mathematics. Also, I taught numerical analysis at Department of Chemistry. And I have 1 published lecture notes, and finally I supervised 2 master students. I think this is essentially what will be presented in here in this presentation. Okay, let us see together a few details on such information. This is, as you see, this presentation includes 5 sections. Okay. We start with the brief CV. So these are my personal information, such as affiliations, contact with emails, nationality and date of birth, etc. And this is the shadow of my photo, which is standard. As information in non-standard analysis, the shadow lump is always standard. But, and so this one is non-standard. Okay? This is my current position, MCB, since the year 2015, and I have an appointment at Faculty of Mathematics, Computer Science and Material Sciences. Next, I show you my academic degrees when I obtained successive college certificates. So the first one I obtained for a free baccalaureate in 1997 as information after 2 years of stopping school. The second one I obtained for DS, Superior Study Diploma from University of Sétif, option functional analysis. The third one I obtained for Magister Diploma from University of Silla, option discrete mathematics, under the supervision of Professor Boudaoud. And after 10 years, I obtained for Doctor of Sciences, option non-standard number theory, always under the supervision of Professor Boudaoud, with the dissertation title, Non-Classical Study on Certain Inequalities Involving the Euler phi function. Now I'm going to speak about my teaching experience. So as any teacher, I start with the TDs of SEM 311 at University of Msila. And all the rest were at University of Gelma. So just for 1 year, I taught Mathematics 2 for Economic Sciences. And after two years, I taught only TDs with Monsieur Fahim and with his beautiful hand series. And from 2007 to 2011, I think for a period of 4 years, I taught numerical analysis 1 and 2 at the Department of Mathematics. Also, I taught numerical analysis at the Department of Chemistry. From 2011 to 2016, I taught both Algebra 3 and 4 and English 1 and 2. And after 3 years, I taught Algebra 1 and 2. Also, just for 1 year, I taught English for doctoral students at Laboratory of Applied Mathematics and Modeling. And finally, this year, I returned to teach Algebra 3 and 4. This is my supervision with the students. So I supervised 2 students. The first topic was on the comparison between the Euler phi function and some polynomials with integer coefficients. And the second topic was on the study of certain arithmetic properties of recurrent sequences and some related numbers such as Fibonacci, locus, etc. And this year I'm supervising a student with his dissertation title on the matrices with integer coefficients. Okay? I have no department activities. So my department activities has at most 1 element, just teaching. So I have an appointment for teaching, and which is 1. But this number 1 has no prime factors. And so the cardinality of my department activities equals 0. Okay? These are my lecture notes. So I have only one published lecture notes, Algebra 3, for the second year mathematics. I think the module includes similar matrices, diagonalizable and trigonalizable matrices, and some applications, also Jordan decomposition forms, and some applications on recurrence sequences, system of differential equations, etc. Okay. And also I have some other lecture notes, which is in produced products. Now I'm going to speak about published works before my doctoral thesis. So at first, these are my fields of interest. So the first, from the first to the third are the primary, my fields of interest. And also I show you my books, my friends. So I always need to these references, especially the third one, which is important to write good introductions in papers. Also, we must know non-standard numbers. So, the numbers used in classical mathematics, such as 0, 1, pi, 10 to the 100, etc., are called standard. Real number phi is infinite small, if and only if for each standard n. So the absolute value of phi is strictly less than 1 over n. And real number gamma is unlimited if and only if the absolute value for each standard n, the absolute value of gamma is strictly larger than n. So a real number which is not unlimited is called limited, and a limited number which is not infinite small is called appreciable. So any real number must be unlimited, appreciable, or infinite small. And so every positive integer must be limited, and that is standard, or unlimited, that is non-standard. Also, these arithmetic functions have been used throughout my research activities. Okay, and also I have used some infinite subsets, for example, WK in classical mathematics, and W infinity and W infinity bar in non-classical mathematics. I have some conferences were very good for me. For example, this one, especially in this conference in Portugal, because I have published this work after three years, and also this one in Oran. On the other hand, some conferences were very bad for me because I didn't benefit anything, even though I have done here some plenary sessions. These are my published papers. So the first and the second are from my doctoral thesis, which are about rational approximation. Also, this one with my colleague from Turkey. So this paper is about units and continued fraction. And also this paper published in Czechoslovak Mathematical Journal, which is indexed by Springer and Thomson. And finally, this paper published with the students of my supervisor. So this is a continuation of my doctoral thesis. I think there is a problem here. Okay. Okay, I told that this paper, the last paper, is a continuation of my doctoral thesis. Also, I have 3 submitted papers. The first one in Ukrainian Mathematical Journal since later time, and also we have a paper which is nearly accepted in Journal of Logic and Analysis, and also the third one. As information, this paper has been rejected too much. The first paper and the third are from my doctoral thesis. I participated for an investigation of 2 research projects. Now I'm going to talk about my doctoral thesis. So this is the work plan, which consists of several topics. And this is the first paper. Based on the following definition, I proved that if the shadow number of the system of reals xi0, xi1, xi omega contains a standard interval AB, then the reals xi for I from 0 to omega are not simultaneously approximable in the infinitesimal sense. And this is the second paper. I gave 2 arithmetic functions f and g, so that the expression, this is the expression, changes sign infinitely often. And the purpose of this study is to give a rational approximation of alpha, which is formed by 2 consecutive primes, PR minus 1 and PR. I think these are the principal goal of my doctoral thesis. Next, I'm going to speak about published papers after my doctoral thesis. I think it's very hot here. This is the first paper, as I told you, published in Czechoslovak Mathematical Journal. I start with the history and some preliminaries. So, recall that d of n, which is called the divisor function, counts the number of positive divisors of n. So, this function decreases as n increases. For example, d of 5 equals 2, and d of b equals 2. Also, d of 8 equals 4, because we have 4 positive divisors of 8. This function is multiplicative, and also we can write an explicit formula for d of n in terms of prime powers that exactly divide n. Okay, as this is a theorem. In 1915, Ramanujan found lower bound of the sequence d of n. but this lower bound was found by considering positive integers of this form, where the I is the ith prime number. Note that Preliminaries was the first who used the notation dm of n for the sequence. D of n, m times. And in 1967, Preliminaries and Imre Katai found or studied the growth of the sequence dm of n by using the mth term of Fibonacci numbers. And they gave an upper bound for all sufficiently large values of n, and they gave a lower bound, okay, but for infinitely values of n. So we are in a position to state the main results. We begin by this notation. In the value ds of n, parameter s means for the power, not for the composition. And also the value delta slm of n denotes ds of n for n equals 1, ds of n plus l for n equals 2, etc. So in view of the previous notation of Preliminaries, we have dm of n equals delta 1, 0, m of n. So in my article, I studied the growth and behaviors of the sequence delta slm of n. So the variable is m. M is the variable. This is the first result. For each positive integer n, there is an order m0 by which we have either 2 or 3. Okay? It seems quite simple, but the proof was very long. I have used several properties of the divisor function, and the fact that every chain of natural numbers has minimal elements. Using Maple, we obtained for the following computations, which verify this theorem for different values of n. These corollaries show that for any positive integer m, we can reach to the values 2 and 3 infinitely often. That is, the order m can be arbitrarily given. And also, this is the second result. Let m0 be an initial value satisfying this condition. Then the Dive-Twin equation holds infinitely often. So the idea of this proof is to construct an infinity of values of this form. We have used the previous Preliminaries and Ramanujan's techniques, and also we have used this theorem, Dirichlet's theorem about primes in an arithmetic progression. As an application of non-standard analysis, if the parameters L and S are limited, then for each positive integer n, the Dive-Twin equation holds for some constant an. In particular, if d of n is unlimited, then the same Dive-Twin equation holds with the ds of n instead of an. Finally, I'm going to speak about my research activities in the future, or rather in the near future. Okay? So, I think that the first step that I will take in consideration is to finish several papers, some of which are in cooperation with Professor Boudou. which are about factorization of unlimited matrices, unlimited Gaussian integers, unlimited recurrence sequences, etc. And also I have some my own works which are about arithmetic functions. Okay. Also I have some hard questions from my published paper in Czechoslovak Mathematical Journal. This is the first one. And I think that this is a generalization of this theorem. Okay, this one. Here S equals 1, and in the conjecture, I think S equals 3. So we ask if for any positive integer n, there is an order m0 by which we have either 64 or 512. And here we see that V3 divides V3 prime. These are some computations for n equals 1. We have obtained m0 equals 5. And for s equals 16, okay, m0 equals 3. Look at this. After 3 iterations, we have obtained this number. Also for s equals 9, put here v9, this number, and v9 prime. By computation, we find that v9 divides v9 prime. Okay, the same question for s equals 10. One day in a conference, someone asked me the following question about the factorization of vk. Okay, I think that at first he looked at here 2 to the 6, 2 to the 9, 2 to the 36, etc. But in v10 prime is not. It remains an open problem. Also, I have two general questions, or two general problems about the factorization. We ask if every unlimited Gaussian integer z can be written as the product of at least two Gaussian unlimited integers. And also for matrices with integer entries and n of z, we ask if every unlimited matrix can be written as the product of unlimited matrices with integer entries. Here k is the larger or equals to. This is a type of factorization. Frankly, in this topic, I would like to publish a long paper in this topic because this topic is a mixture between elementary number theory, group theory, matrix analysis, and also non-standard analysis. And also we can add algebraic number theory when we use the matrix A formed by entries with integer entries in Z. And finally, also I will show you how to find open problems about arithmetic functions. That is, how to solve, how to find Dirac equations and inequalities. At first, we must know my numbers, my friends, but this is not enough. We must know the properties of my numbers, my friends. My numbers, my friends, this is a book published by from Argentina. Okay, I think that there are more than 1,000 types of my numbers, my friends. these are such examples. For example, even, odd, etc. Even numbers with all numbers, illegal primes, safe primes, etc. So we can use such types of positive integers to solve a Dalton equation of the form E. So assume that you have a Dalton equation. At first, we search for necessary and sufficient condition, and maybe no solution, but we must have the proof. In this case, I think that there are two inequalities, strictly large and strictly less, and either of the inequalities holds infinitely often. And here we ask how many my numbers, my friends, are there. Also, we can make an extension to study the previous inequalities and equations on the set WK. And as an application of non-standard analysis, we can use external subsets, such as W infinity, W infinity bar, etc. It's the same when we have finite number of solutions or infinite number of solutions. I finished this presentation by the following expressions. So, Paul Erdős said that N is ever the richest set at all. مجموعة أعداد طبيعية من زمان وعلى طول هي أغنى مجموعة. And also Hardy said that the elementary theory of natural numbers should be one of the very best subjects for early mathematical instruction. It demands very little previous knowledge. These are some references that I have been used throughout my research activities. And also I have a good question. Who are the biscuits of number theory? I think that this man is eating the number 987, which is square free. Okay? And this is a non-standard writing, which can be spelled. Thank you so very much for your attention to this university habilitation in mathematics and non-standard number theory. And as you see in standard writing. Okay, well, shukran.